All right, hello everyone. If our panelists wouldn't mind turning on their cameras and joining us. So welcome back to the main meeting room of the Future of 3D CP. If you were able to attend our networking session, we hope you had an incredible time meeting with industry professionals and 3D printing enthusiasts from around the world. Our next event will be a contractors panel, Past Achievements and Future Frontiers, where we will hear from Jim Ritter, who is the CEO of Printed Farms, Tim Lankau, who is the CEO of Hive 3D Builders, and Zachary Mannheimer, who's the founder and chairman at Alquist 3D. As a reminder, this webinar is being recorded. I would like to start off with a brief introduction of each of our panelists, and then we'll begin our discussion. To begin with, our first panelist is Jim Ritter. He's the founder and CEO of Printed Farms, which is a leading 3D construction printing company dedicated to bringing turnkey solutions to people within the 3D CP industry, and he wants to make it mainstream use. Jim crafted the idea for Printed Farms in 2016 when he saw the need for sustainable building methods on agricultural land. In 2019, Jim purchased his first machine for Printed Farms and quickly got started on his first agricultural building project in 2020. In his time as CEO, Jim has overseen the building of the first permitted 3D printed house in Florida, the first print in real elements without cover, the creation of the largest 3D printed structure, and the completion of the largest 3D printed home in Florida. Quite a resume. Jim is a graduate of Dartmouth College and has over 20 years of experience as a builder. In the past 10 years, he has purchased, developed, and sold over $20 million worth of horse farms and houses. And we are very excited to hear his incredible insight on this panel. Just so everyone's aware, we just spoke on the phone with Jim. He's actually running back from a job site. So we're going to start our questioning with Zach and Tim while we wait for Jim to join us. Our next participant is Tim Lankau, CEO of Hive 3D Builders. Before his entrance into the 3D CP industry, Tim received his Bachelor of Science in Business Administration from Texas A&M University and his JD from Washington Lee University School of Law. He began his career as an associate at Vincent & Elkins, a law firm dedicated to helping its clients navigate the most complex areas of laws through their full-service platform. He then made the move to Ware, Jackson, Lee, O'Neill, Smith, and Barrow, where he worked as a partner. His immense success in law and intellectual capacity have set him up to be a phenomenal leader of Hive 3D Builders. In his time as CEO, Hive 3D Builders has completed the development of a tiny home community in Round Top, Texas, with studio, single bedroom, and two-bedroom models. His team has also printed a single-family home in Burton, Texas, featuring innovations never before seen in 3D printed houses, including parametric wall designs, foamcrete wall insulation, and pigmented concrete layers. Thank you so much for joining us today, Tim. And our final panelist is Zachary Mannheimer, founder and chairman at Alquist 3D. Zachary studied theater and philosophy at Muhlenberg College and spent his first post-grad years in London and New York City creating and operating several experimental theater companies. And I love theater, so I love to hear it. In 2007, Zachary's path was altered by a road trip to Des Moines, Iowa, where he was inspired to establish the nonprofit Des Moines Social Club. In 2020, he co-founded Atlas Community Studios, a studio dedicated to addressing community and economic development in over 25 states. His career took a turn when he recognized the need for quality, affordable housing in America. This passion led him to establish Alquist 3D, a 3D printing company dedicated to printing 3D homes in underserved communities. Zachary's contributions to the industry have been recognized in the New York Times, Washington Post, CNN, and The Atlantic. Zachary resides in Iowa City, and outside of his work at Alquist, he is passionate about exploring rural America and is a big Philadelphia Eagles fan. Thank you for joining us, Zach. We really appreciate it. So just to get us started off with our discussion, I kind of want to focus on the past and what y'all have accomplished. Tim, I'll go to you first. As a contractor, how do you decide what projects you actually want to pursue? And considering this is an emerging industry, how do you garner consumer attention and interest in having a 3D printed home? I think you're muted right now, Tim, if you want to try to unmute yourself.
There we go. That's
Gotcha.
better. Sure, and that's a great question. I'm not sure I would really classify us or Zach or Printed Farms as a contractor necessarily, in the sense that we're not, at least we aren't hired by people to build buildings and houses on a contract basis. Most of what we do is actually build houses and sell them to end consumers, or work with developers in kind of a joint venture type context, as well as, develop all our own equipment and mixing systems. And so there's a bit more vertical integration there. So when it comes to choosing projects, I think probably all the panelists here have a backlog at this point. So from our standpoint, interest in the product has never been the issue. Finding stuff to build has never been the issue. Building it in a way that makes sense economically and we can make money on it, and the client can make money on it, it is the harder part. So we have everyone here has had a lot of media attention that drives traffic to us. Word of mouth drives traffic to us. And at the end of the day, I think if you can build something different and better for a little bit less money than another way to build it, there'll be no shortage of projects. If you're focused on a different market, which is building things maybe that cost more but are better, that's more of a niche market. But so far, we're trying to deliver the projects a little bit under market, which means that we have a backlog. So it's just a matter of choosing the ones that make the best sense for us at that time.
Yeah, I mean, that's excellent to hear that there's so much interest. Zach, same thing to you. I know the mission of Alquist 3D is kind of to get into these underserved communities. How are you doing that, and how are you selecting your projects with that mission?
That is really how we drive it. I would echo everything Tim just said. And just to start out here, just want to thank you guys for putting this together. It's rare that we get to have this opportunity to actually talk to our colleagues in an environment like this. It's great to see Tim and Jim. It's great to be on a panel with them. Pioneers, good to see Jim. And it's great to just get a sort of a global group together. And it seems like that's who we have on this. So congratulations to you guys for putting this together. But that is how we choose our potential projects. Tim's right. We have no shortage of backlog. We get new projects every week that come in the door. Obviously, we can't tackle all of them, but we do look specifically for the ones who are going to be the projects that are going to be the most impactful for the people who need it.
Yeah, that's incredible. And Jim, I see you were able to join us. Welcome. We were doing a discussion on what projects we are selecting and how we make that decision, but I would love to shift the conversation for your specific environment. I actually had the honor of visiting you in West Palm Beach last semester, which was incredible. We got to see that horse barn print, absolutely stunning. I'd love to hear how your role differs given the environment you are located in, a hurricane zone with all these different code constraints. How do you have to navigate that in your projects? I think you're on mute right now, Jim, if you want to unmute yourself. Should just be at the top right.
Can you hear me now?
Yes, we can, Jim. We got you.
Well, I'm the least adept at this compared to my colleagues, so people have to bear with me. The bottom line is we exceed Miami-Dade code by the nature of the materials we use. And 90% of our buildings are conventional anyway, post and beam and that. So by utilizing 3D CP for the qualities of flood resistance and the fact that it's stronger than the materials that are accepted by code, that's how we meet the Miami-Dade code, which is obviously 180 mile per hour winds and a lot of other little things. Impact glass, we can't just use normal glass, and everything has to be tested with a 2x4 at 250 mile per hour. And the good news is we're supposed to have more hurricanes this year than normal, so we'll find out.
Well, I'm sure we'll see your structures standing strong, even compared to the traditionally constructed houses. So it's super interesting to see how these homes fit in these different environments. I'd love to have a conversation about your printers. I think at times, the line between 3D print manufacturer and 3D entrepreneur can become a little blurred as you guys are making these upgrades and custom add-ons to your machines. Tim, we can start with you. Can you give me some insight into how you're adding these custom hardware solutions to the printers that you use and how you determine this for each specific job? We got you back on mute.
There we go. Sure. So the first house, the big house we did, we built a printer with another partner on site for that house. So that was a big gantry style printer. And now we have 3 robotic arm printers, and the robots are made by ABB, and there's an integrator called Seabay that makes a little crawler for it. We've taken those off the crawler and used them off the crawler. We do new control boards on them. We have to rewire the whole thing. I mean, so it's like Sisyphean. There's not much left of it by the time you've had it for a year, other than all the steampunk stuff you do to keep it running and going, and really trying to use it in your unique situation. I mean, everyone has different weather, different site conditions. Some of these machines are made to be operated indoors. Some are made to be operated outdoors. So it's still new enough to where I think having that kind of vertical integration, being able to kind of start with some group of hardware, just like you're building a computer in the 90s, and mixing and matching the parts that make sense for what you're doing.
Yeah, that's incredible insight. We had a panelist this morning describe the 3D printing manufacturing almost as rocket science. So it's interesting to see that you've had that similar experience of build. Zach, I'd love to turn it to you. Same question. What does y'all's upgrade process look like?
Tim's very right that this is kind of like building a computer in the 90s. We're sourcing parts from all over the place. We're on our 3rd robot now. So we've used Cobod, we've used a Buffalo, we're now using a Rick printer. It's very similar to Tim's. Ours is a KUKA arm as opposed to his, but they're very, very similar. Our arm is on a mobile chassis, so it can be remote controlled. It can go up to 20 miles an hour, which is ideal when you're going from site to site. When you're working in one area, we don't have to use tractor trailers to move this thing around. We can put it on a flatbed. It deconstructs in about 3 hours. It constructs in about 3 to 5 hours, depending. But we really like it. The gantry printers that we were using are great. They're great printers. They're kind of overkill for the work that we're doing. When we're looking at single family or smaller homes, gantry printers you're never really going to get to your price point that you need to by using one of those at the moment. I think that'll change in the future. But when you're doing larger projects, I think the gantry printers are really strong, but the robot arms are nimble. They're easy to learn, and it's been helpful to us to really create a workforce development curriculum around it.
That's incredible. Jim, I know you have some exciting things with your printer in the works. We'd love to hear what you have to share.
Well, I have to second with both these gentlemen and Zach. The gantry printer, there is no one size printer or one type of printer that does everything. They all have their uses, and even on our last project, we had an ABB robot arm that printed the tops of our columns, and then we shipped them in. They were prefabbed by Printera, and we collaborate with them. They can do a finer print and everything else. Like Zach found out, the gantry system, we could never set our gantry up in less than two days. And obviously we had to move our system 5 times for that size building. So we also are dabbling with a more mobile system. As you guys can see, I'm totally computer illiterate. So what we did in January is we printed a wall without a computer, and we can print with just a machine without a computer. You can't do 3D printing without a computer. You can't do building integration modeling without a computer. So don't get me wrong, it is the end all of what we're doing. But we wanted to break it down to its simplest element is, all right, what you're left with is a wall. So in January, we printed a wall with, manually with a construction machine and said, all right, we can do this. Now, is it practical? No, it wasn't at all practical. But we feel that, and what they said about the 90s, I can go back farther than that, which is to the original Model T. That's what I go to, about 2005. They had the Model T, but we didn't have any roads. This group is building the roads and the map of how to build and integrate all these different products into 3D CP, which is just one small aspect of it, the printer. And then you have all, which I feel the material is the most important, Yeah, you have 50 different things that go into a building project to make it a house. And so, that's where we're coming from.
Yeah, excellent insight. Really appreciate that talk. I think we'd love to hear a little bit more about the cost. I know, there's all these promises for this industry that we're going to have this more affordable housing. We're going to get there. I'm really curious to hear currently, and y'all's opinion and your perspective on your previous projects. What is the cost currently compared to traditional construction, and what is your vision for the future, both optimistically and conservatively? When do you feel it really is going to become more affordable? Tim, we can start with you whenever you're ready.
Yeah, so costs it's a very actually slippery comparison to make because the first thing you have to start with is what are you comparing it to? What is the traditional product that you're trying to compare the cost to? And where are you pulling that data from? So people have been trying to pin down the costs of stick framing a house in any individual market forever, and have done various have had very success in doing that. I mean, there's data out there, but it's so hyper localized. Every county is going to have a different cost than the next county over when it comes to the labor pool, when it comes to materials. So when you say, we think we are saving money by doing this, that's going to depend heavily on where you are, what the project is, what the location is, and then when you try and break it down to your line items, again, it's really difficult to find the numbers to compare it to. So our guiding light has been, we try and do that breakdown. We're constantly doing that breakdown. It doesn't make sense for us to be doing this at all if there is not cost savings in doing it. And at the end of the day, what matters to us is that the finished house that we build is going to be sold for less money than a similarly sized house in the market it's in. And so far, all our projects have done that. The first house we did. Pardon? Sorry. So the first house that we built is going on the market at a high price, but it's in a very fancy area and it's a big house. So we're selling that about 20% lower than the area comps, and we have multiple offers on it, so that's great. The smaller homes we did in our recent development, we sold for a very low cost, but we didn't have a good enough margin on those to do that again. We ended up making like $1 on the project, but they were, we sold a house for $85,000, a 2-bedroom house. So it's a rental house. It's not, it's got a kitchenette, doesn't have a full kitchen, and like I say, that margin was too thin for us. But we think that there's definitely a path to sustain cost savings. We don't have the data on it yet. After doing 7 houses, we just haven't done enough to really know how sustainable that is, whether it's going to be like that everywhere, whether we've just been kind of lucky so far in picking the markets and the areas we did them. So circle back in 2 years, when we have 20 or maybe 100 houses under our belt or something like that, then we'll really be able to know if what we're doing is working on costs.
Really appreciate your honesty and openness with that, Tim. I think even my team has seen the difficulty in finding this data as we've been exploring this industry. So 100% echo what you shared. Zach, to you, what are your thoughts on this cost affordability for the future?
It's the $1 million question. And I would agree with everything Tim said. And to me, this is a scale game. The more that we can be printing at the same time is how we're really going to be able to lower our costs. But today, the cost is not getting lower than traditional stick build, especially if you're just building 1 unit. If you're doing 20 or more, our numbers suggest that it can be lower. We have not done that yet, so that's in the plan for this year and next. But to me, there's really 3 elements here for how we can lower the cost. The first, I believe all 3 of us are already doing and have discovered, which is moving away from a gantry style printer to the robot arm is much more cost effective. Certainly the gantries will come back into play for other projects, but for what we're doing, the robot arms are proving to be better at a cost effective rate for that. Also, they need to move faster. The second piece is the material itself. There's a dozen or so materials out there globally that can be used. Obviously, there's hundreds of types of materials that can be used, but there's a dozen or so popular ones that can be purchased today. Each of our groups I know have experimented, and some have been successful with creating our own material. Everybody's working on that, but we really need to get the cost down to sub $200 a yard. That to us is the measuring stick for where we need to be to really make this cost effective. In order to do that, we need to be producing the material locally. So we're working on that now. Lots of other groups are working on that now. There was just a group discussion in the chat room I overheard towards the end about how to get that done. So it's sourcing your local things such as sand, gravel, ash, etc., shipping in your additives potentially if you can't find them locally, but getting that cost down of material. And we're not there yet, below 200, but we're working on it. That's where we need to be. The third and possibly biggest piece for how we really achieve cost savings is experience. One of the big things that the 3D industry talks about in terms of cost savings is labor savings, is having fewer people on the job site. If you have super experienced folks on the job site, you can get this done with 2 people. We're not there yet today. I don't know any group that's there yet today. And so what we need is a better experienced troop to be hiring from. It's very challenging to go off on the street and find people who are experienced in 3D printing a home. They don't really exist unless they already work for one of our colleagues here. So something we've done to address that is we have now a program with Ames Community College in Greeley, Colorado, that is a certificate course, a 35-hour program. Anybody can take it with no prerequisite needed. If you take that course, we're going to hire you. Tim's probably going to hire you. Jim's probably going to hire you. Many other people that rhyme with Tim and Jim are going to hire you. So that's the thing that needs to spread. We're working on that. We've got a lot of colleagues in the industry that are going to partner with us on this to really get this out there. But we have more experienced people, less expensive material, and faster robots. That's how we can achieve the cost savings that everybody wants to get to.
Yeah, really appreciate that insight. We've definitely heard some similar messages being relayed by our other participants this morning. So glad to hear that. Jim, to you, do you have anything else to add on this point?
Yeah, first of all, we never compare to stick-built. If you look at any catastrophic climate event, you're going to see a stick-built building being catastrophically destroyed. The hurricanes last year on the West Coast, they're still digging out. So and actually at FAU yesterday, a gentleman, a professor, gave this talk on climate change. And for Florida, the seas have raised 10 feet since 1992. You can believe it or not, climate change is going to drive our industry because we have houses that are sustainable and can withstand these climate events. For our building, we were at $220 a square foot. Complete for that building. It's a horse barn, but this is a luxury horse barn. We're in a very wealthy area. The range is 200 to 250, sometimes 275 for an equivalent building. Our building went up for sale. It sold within 3 weeks. And the guy jumped on it because of the quality. Obviously, we're using better materials than conventional. And he scoffed it up. It sold for about $4 million, 3.99, some ridiculous, so, and it's hard to explain on a, 5-acre piece, that kind of money. You'd have to see where we are and understand the numbers. The Clay Street house sold for about $240,000 with comps of $65,000, but in my world, those are tear downs. But again, it's a concrete house. You can't compare our structures to block or stick. As Adrian, who works for me, says, you can't compare a Borscht to a VW. We're building more sustainable, 100-year sustainable buildings. We're not building houses like they do in Florida that are 20, 30-year-old houses, and generational wealth builds into it, where you can pass on this house for 2 or 3 generations, and you can cut a hole in our house or any 3D house wherever you want and add on and do whatever. So it's a lot of cultural differences, but as far as price points, we feel good at $220 for that project, considering what Zach said. We know we can do better. We're already experimenting with a 3-in-1, paint, insulate, and a stucco finish, because we don't need a stucco finish on 3D in one application. In fact, that's why I'm late. We were screwing up and I got caught up in it. So by adding applications, like Zach said, the labor pool. Well, where's your labor pool? We have the same problem. In the middle of our project, One guy breaks his leg skateboarding, never give a guy a day off for Thanksgiving. The other guy burned himself on his boat. And that's half my crew. I had a 4-man crew, and it wasn't funny, because it takes 6 weeks, 8 weeks to gear everybody up. Try to get a guy who works right to left to work left to right on a construction site as you're going. And as Zach knows, yeah, your job is impacted. So, and the other one is scaling. When you've got thousands and thousands of people, 10,000 people, I think there's 60,000 general contractors in Florida alone. When everybody's utilizing this as their shell production, of course, the big companies like Cemex, Heidelberg, you name it, the cost of print material is going to drop immensely because now they have to stop a productive line, print our custom material, and then ship it out. Of course, it's exorbitant. I mean, this is just common sense. We're compared to industries that are already scaled up, huge factories. Some of them are, subsidized by the government, and they go, oh, well, why can't you beat their price? Well, it just doesn't work that way. So that's been a pain in all our butts since the beginning. Cheaper and faster was the dumbest thing to say because we're not scaled up, but we will be scaled up within 5 years, I think.
Yep.
Yeah, I think that's an excellent point. Sorry, go ahead, Zach.
Sorry to jump in. I
No
want to
worries.
just echo something Jim was saying. I completely agree on that. We can't keep talking about this as in a 3D home versus a stick-built home. There are so many other benefits to a 3D home versus stick-built, and eventually the cost will come down. We're all working on that. So we're all beginning to share data. That's going to happen. But in terms of the world that we live in today, where natural disasters are unfortunately the norm, we have to change the way that we do construction, not just to sustain and withstand the storms, but to ideally prevent the storms from happening in the first place and contributing to carbon going into the environment. What all of our practice is doing, and this industry as a whole, we can drop the amount of carbon going into the environment collectively as an industry. It's going to be a while before we make a significant impact, but we're all working on that. And so the more resources that go to it, the better. So there are other benefits to this method outside of just cost.
Yeah, I think that's excellent. I really love your point on like the importance of collaboration, all of us working together towards a shared mission. I mean, that is the whole goal of this webinar. So it's great to hear that, we're working towards that more collaborative and innovative future. Tim, I know we've brought this up a bit, but I would love to hear your perspective on like this focus on sustainability. As we look towards the future, what is your company's focus on going green going to look like? And how are you making efforts to continue to innovate towards this more sustainable life we're all trying to achieve?
Yeah, so our company charter is to build affordable housing in an environmentally friendly way. That's in our charter, and so that's where we are required to be focused. So we don't use cement in our mix. We mix our own materials. We have a volumetric system that we bring them all in and mix them on site, and it allows us to adjust them. And we use a posit slag, which is like 100% fly ash. So fly ash being a recycled product, we get a carbon credit back for it. And and you can call it carbon negative, you can call it carbon neutral. It depends on how you do your credits. So that's the big knock on concrete is it does have a high carbon footprint. There are a ton. I mean, this is a very mature industry at this point on green friendly concrete and things that you can replace some of your cement with. Things that there's tons of stuff out there. It's just a matter of really getting the time to experiment with it, get the mix right, make it printable. Print with it, see if you can get the numbers right. So we're looking at several different materials. We like the one we use now. With the posit slag, and so that's our main focus. And the other idea is with additive manufacturing. Ideally, you're only using there's less waste. You're printing what you're using. So when you go to a traditional construction site, you'll see a big huge debris pile of sawed off ends of boards and siding and just a bunch of stuff, and we have less of that when we 3D print because the computer is working pretty precisely. It's putting it right where it needs it. It doesn't create that massive amount of waste. So that's on the build side, and then I can echo what everyone else says. you can look at the carbon footprint you put into a house, and it's kind of a folly not to look at what the lifespan of that house is going to be after you built it. So if you build a concrete house that's going to last 200 years or longer, that's going to have a much lower carbon footprint than a house that only lasts 20 years, because you have to replace that whole carbon outlay every 20 or 30 or 40 years. So that's a really important element to look at too, is what's the durability and the longevity of the structure, so you don't have to repeat whatever carbon you're putting into the process. And then the last leg to the stool is energy efficiency. So by nature, a monolithic concrete house has a very good air seal on it. The next house we're doing is actually going to be a certified passive house. I think it's going to be the first one. We've actually started on it. It'll be the first passive house that's been done 3D printed. But we were able to get that passive house certification at a much lower premium than you would get if you were stick framing the house. Because when you stick frame a house for passive purposes, you have to double stud all your walls. You have to just put in tons and tons of insulation, and you have to do all this really exotic sealing to keep the air seal acceptable for that certification. Our walls come pretty well sealed, and the foamcrete insulation we use on the inside is pretty good insulation, and they also have that thermal battery effect. So the walls just contain a lot of heat energy, and so you're able to regulate the temperature kind of naturally through the heavy materials. So those are the three legs to the stool from our perspective. It's finding carbon-friendly materials, building structures that are going to last a really long time, and building energy-efficient structures.
Yeah, that's incredible. I think there's so much promise and excitement in this industry, and I'm really excited to see, as y'all continue to innovate, how this really can contribute to a better, more green world. I do see, I think all of our speakers and panelists have shown that, everyone is striving for that common shared goal. So it's really promising and inspiring to see. I'd love to kind of take us back to the central theme of this event, which is the future of 3D CP. And Zach, we can start with you. When you look towards the future, what do you see happening in the next 5 years? What do you think this will do for your company, the industry as a whole? Anything you'd like to add on that kind of outlook?
The next 5 years will be 3D printing spaceships to go to the moon. I'm joking. That's not true at all.
I love it. Let's make it happen.
Let's make it happen. Let's make Tim, get on that. In the next 5 years, what I think is reality is that you're going to begin to see a lot of these types of 3D printers on most job sites in America, complementing what's happening on the human labor side in some way or another. It's becoming more evident that there are so many other uses for these machines besides home buildings. In fact, in many ways, home building might be the most challenging thing to do, especially when we're talking about getting it to a cost-effective standpoint. We've begun printing infrastructure in Colorado. We're printing retaining walls, curb structures, park benches, tree surrounds, sidewalks, things like that, in production in a manufacturing space. So we're planning on expanding that. I've talked to many other 3D companies that are also working on that as well. But in general, in terms of the 3D world, there's about, and I'd be curious to hear Jim and Tim's thoughts on this, but I think there's probably around 20 groups in America right now doing this work in any meaningful way that's a practical production way. There's probably another 50 that are studying it at an academic level, which is great. But I think that we're going to begin to see hundreds of these companies come online in the next couple of years, especially as we see workforce development as a major opportunity. There was an interesting stat that came out a few days ago about how technical colleges and community colleges have seen a 16% uptick in interest and students on their campuses, and many young people are moving into those types of careers. 3D is a really exciting way to do it. If I've learned anything in the industry, it's that young people don't want to swing a hammer and build homes like we have for the past 100 years, but they do want to play with a giant robot. And so we can use this as a gateway to get young people back into the trades, and not just in 3D, but we still need carpenters, electricians, plumbers, HVAC folks, roofers, etc. And this is going to inspire thousands of new jobs in this industry in the next couple of years, in addition to us printing other aspects of a home, and not just out of concrete, but out of other materials as well. We just met with a group that's printing whiskey. It is delicious, which is interesting. Don't eat too much of it, of course. We're printing with chocolate. There's groups that are printing out of wood, fiber, glass, etc. So we're going to see more and more of this as we grow. And I think the real success of this industry is going to happen when more collaboration happens amongst the groups that are currently pioneering this work. The more that we work together, the faster that's going to come.
I love that. It's a great mission that we're all striving for. And I really love that focus on, getting young people back interested in this. I know we have a lot of students on this call who are passionate and curious about the industry. So I really appreciate you highlighting that importance. Jim, same question to you. What are your thoughts on the next 5 years? What do you see happening for your company and the industry as a whole?
Well, we stopped after the last project to basically regroup and say, all right, what went well, what didn't go well, and everything else. So along the lines of the other gentleman, changing our printer system, our delivery system that we're going to come out with at the end of the year will be totally different. We're already hopefully working with a group, and as you know, Miami-Dade is a very tough area to do it with, which would be a printed resin roof system that would have 5,500 kilowatt solar already built into the roof. And it would also take out the need for a membrane. A membrane is the tile, the paper and everything else that you put on, after your plywood. So our goal is to take all the wood out of a building. That's environmental, but also, termites, you name it. Florida's not good with wood. We feel in the next 2 years that we can have totally 3D printed shells, that except for the windows and doors, everything is 3D printed. The doors could be 3D printed, but that's not our game. And then if that's the case, obviously we want these environmentally, like Tim said, houses that, they charge your car, they do this, they do that, they heat your pool, whatever, So again, it's all circular, and it's going to be a logarithmic curve. What's happened now for the last 4 or 5 years, as Zach alluded to, I think we started out with 40 people in the world, and now they had a thing, Jared Gross, there was 400, which shocked me. I have no clue what other people are doing. I have a hard enough time getting my own job done. But the bottom line is, yes, it is going to be logarithmic growth, and it's already been that way. So, but it has to be thousands of people. But it's just an evolution. If you were in a car factory in the 50s, you had thousands of people. Now you go into a car factory and you can't find a person. It's all robots. That's all we're doing. Because as it's been alluded, my real profession from 14, I'm still doing it on the side for my own horses, is I put shoes on horses. That's 2,000-year-old technology. I'll tell you, it's no fun. Most kids can't get under a horse and put a set of shoes on. They're not going to work that hard. And I'm almost 70. So you have to evolve. The world's evolved, and not in a bad way. I think they're smarter than we were. Why should, we used to put 45,000 bales of hay in a year by hand. No farmer does that today. So the building industry is actually retarded in its approach. I hate to be cruel. And all we're saying to them is, hey, why work so hard? Why do it this way? Why not have sustainable housing? Another thing is, in Florida, 50,000 people lost their insurance along the coast last year because no one will insure them because of the houses they're building and the damages. So we're in a revolution, and it just has to be adapted. We basically are there. We could do it tomorrow if more and more people would adapt to it.
Yeah, appreciate that insight, Jim. With our last 5 minutes, Tim, you'll wrap us up. Give me your pitch for the next 5 years. What do you see?
I would say that automation in construction is inevitable. It's the last major industry to automate. What the precise form that automation takes is up in the air. So 3D printing in particular is one form of automation. So as AI begins to kind of take over more and more of our intellectual work, there's a huge industry potential to how you translate that intellectual work into the physical world. And the bridge to that is going to be in robotics, and it's going to be in augmented reality. And we do both here at Hive. We have augmented reality integration to our to our robotics, but it's how we have the AI programs working on the architecture side of it, designing the buildings, automatically placing the robot. And all, so AI is already ahead of us on that. And then we have to translate that into the physical world, and that's where the robotics come in. 3D printing in particular, I don't know. It's either going to be a niche industry where we're building really architecturally significant, awesome, expensive houses that can do all kinds of crazy walls and curvatures that you can't get any other way, or it's going to be mass adopted because it's a more cost-effective way to build. And that's all going to be a function of price. So if these things happen to get the price below the cost of doing this any other way, then it's going to be mass adopted. But that's not inevitable. That might not happen. If that doesn't happen, then it's going to be a way to build, unique and particularly strong and sustainable homes. I'm not sure which one it is. I'm betting on the latter. I'm betting on being able to getting the cost lower. I know there's going to be automation everywhere in construction in 15 or 20 years. I don't know if it's all going to be 3D printing or it's going to be some other technology that comes along.
Yeah, very exciting insights. I think we've definitely seen from our speakers today, the architectural capacity of this technology is something that cannot be understated. I mean, the beautiful, unique housing structures and just structures at all, not even houses, that you can make with this is something that, is not talked about a lot, but it's something that I think is really important and a cool highlight of this industry. So thank you for mentioning that. With our last couple seconds, whoever wants to take this can, let's keep it short since we only have a couple minutes left, but we have a question from the chat that is interested in learning more about site prep. We have companies out there that, claiming to print in just a day, which I'm not sure if that's true or not. We'd love to just know what goes into the site prep real quick from one of you.
Well, it's impossible. First of all, you got to do your site work. Then you got to do your soils. Then you got to bring in and do your site work. Then you got your inspection. Your first week is getting your slab done, whether it's conventional or otherwise. Then you've got inspections in that. Your second week is printing your walls. This is the best we can do. And the third week and into the fourth week, you're dropping your rebar and doing all your rebar work. Then we're pouring columns and beams from our prints. And then, of course, we got to fly the roof. And I'm sorry if my jargon people don't understand, but flying the roof is putting the trusses on and the plywood. There's no way. But because we do the interior walls and we do this and we do that, they're not building much faster with block. Again, I do nothing with wood, but in 3 weeks, you're going to have a shell done in block, but they're going to be framing inside, but we're going to be flying the roof. So, yeah. And we've got the electrical outlets in, everybody's doing the same. We've got the rough plumbing in. So we've done 3-4 trades in that 3 weeks, whereas in 3 weeks, they've done 3 or 4 trades. So again, we're pretty sure we can build at a certain level with anybody if they want to pay for the quality, but people don't want to pay for quality.
Yeah, that's a great insight. Thank you so much for highlighting the importance of the way each step is taken, even making that comparison to traditional. Unfortunately, we will have to wrap up this panel right now. Virtual round of applause for everything that y'all shared. This was incredibly insightful for me, and I'm sure for the rest of our audience. So we appreciate y'all taking the time to speak today. We're going to take around a minute little break while we transition to our next event, but please stay tuned because we have a lot more exciting stuff to come.
Thanks, everybody.
Thank you all for having us. It was fun.
Thank you.
I apologize for my lateness.
You're good, Jim. We appreciate you being here.
Anyone that has any additional questions or whatever, you can always find me on LinkedIn, our website. Just feel free to send me an email. I'll answer them all.
Yeah, if y'all want to put your LinkedIn or emails in the chat, that'd be great so our participants can access them. We're going to switch over to our next event now. Appreciate y'all.
Thank you very much.